Before we start our second part of the review notes, I want to quick review what you did yesterday. We had two shapes in our homework yesterday. Which were they? Which ones were they? Parabolas and circles. Okay, so with a circle, what's our basic formula? Okay. All right, so if I were saying, given this equation, I want you to come up with the key features of it, tell me what the shape is, and graph it. What would the key features be? Right, can you find the center and radius of that? Okay, you'd have to list those. Those would be the key features. It's not going to say, tell me the center and radius, because then I've given away the fact that it's a circle, right? So it's going to be more generic, just like your worksheet, your review packet is, okay? It's just going to say, what is this shape? What are the key features of it? And show me the graph. All right, then we looked at parabolas. What were our basic equations for those? Say it again. Four P. Okay. Or we could have the other version, right? X and Y switch. So we could have y minus k squared equals 4p x minus h. All right. How do you know that it's going to be a parabola? When you look at the equation, what is it about it that shouts out at you? This is a parabola. Only one of your variables is squared. Okay, that's the key. All right. You also often have x's on one side, y's on the other. I say often because I could always move that whatever I have on the right side over here and have it equal 0, right? I mean, it could change the format a little bit and you'd have to rearrange it so it looks like these. Okay, but the key there for you is it's got one squared variable. Okay. This is the only conic that has the letter P in the formula. What does P stand for? Okay, now, Nick said the distance between the focus and the vertex. You want to be really careful because P can have a negative sign on it, right? In all the other shapes, our whole ABC stuff is always positive. It's of distance, okay? P is called a directed distance. That means we give direction to it. So when it's positive, we know that it's opening, it's moving from center, from vertex to focus, either to the right or up. Okay, and if it's negative, it's moving from vertex to focus going left or down. Okay, so the sign there is important. How do you know which way it opens? Like up, down versus left, right? Okay, so the x squared kind open which way? Those are the up and down ones. And it might seem a little opposite of everything else that we've been talking about, right? Because when we talk about ellipses, if your vertex is moving in a y direction, right, we say A is paired up with y, and that helps us figure that out. You guys have been graphing x squared graphs for a couple years now. So when you get to the parabolas, always think in your mind, okay, I know what an x squared graph looks like. Y equals x squared is our basic parent function, right? If it's negative, we flipped it upside down. But you should know those are the up and down kind. It's the y squared ones that were the new ones this year. Those are the side to side. Okay. What is the h and k in this equation? Help me find. That's your vertex. Yep. Okay. And really watch, especially on the second one here, right? Because your k value is first. So when you're listing that vertex, make sure you pull the h value first and then the k value. Okay. So that was yesterday's focus. Today's focus is going to be on the other two shapes. What's our generic formula for the ellipse? which ones flip-flop to get the other version of this? Right. So how do we know if A and B can move around, how do we know which one's A? A is the bigger one. Yep. And what's the relationship between our A, B's, and C's? Okay. So A is always bigger than B. C squared equals A squared minus B squared. What is A? I mean, what does it mean? Perfect. Distance from center to vertex. What is B? Somebody else. Good. Distance from center to covertex. And then C? Center to foci. Okay? So if you know A, B, and C, you should be able to graph it. When I say what are the key features for an ellipse, you're going to say I need vertices, covertices, foci, center. And in order to find all those points, I'd have to know A, B, and C. Right? Okay. Then we have our last one, the hyperbola. All right. What's our equation for that? How is it different from the ellipse? It's a minus. So you see a minus in there, you know it's going to be a hyperbola. We've got something minus something equaling 1. Okay. What goes in the first position? A squared. A squared is always first, right? And then B squared is here. And the top pieces now can flip-flop, right? So we could have, say, an x minus h squared and then a y minus k squared, or those two can move around. Okay? But keep in mind, with a hyperbola, A is always first, not necessarily the biggest one. Okay, what's the relationship between A, B, and C here? All right, so remember, if it's a minus here, it's a plus here. Opposite for the ellipse. Okay? Your A, B's, and C's get you basically the same thing as they did in an ellipse, with one difference. What's the one difference? What'd you say? No, I'm talking about when you graph and you mark off your A's, your B's, and your C's, right? Your A's get you from center to vertices. What about B? It gets you from center out to the other edge of your box, right? It's there to help you make the box the right size, but we don't call it a covertex, all right? Because in an ellipse, your actual graph is going to touch your vertices and covertices, right? It goes through all 4 points. In a hyperbola, it doesn't touch those B pieces at all, okay? So we don't call them that. All right, the other thing with a hyperbola that we have to give is what? The asymptotes. How do we find those? Remember the basic formula? Okay. What goes in front of M? Plus or minus Y? Yeah, there's two asymptotes, right? One has a positive slope, one has a negative slope, but the rest of the equation matches. Okay, so we just shrink it down and write it once. The M is the slope of your line. So you're going to count rise over run, right? I wouldn't say memorize, is it B over A or A over B? I would say, look at my box. How much am I moving up versus how much am I moving over? Okay? Or you can look at your A's and B's and say, which one goes with Y, right? That's a rise. Which one goes with X? That's your run. All right, we're going to try a few of these. I'm going to do a couple with you, and then I'm going to give you some time. I'll pause the video and let you try a couple. Okay? So first one, what is it? I heard ellipse. Agree, disagree? Yes. How do we know it? The plus sign in between. Okay. So we know it's an ellipse, and if we know it's an ellipse, we can picture our graph, right? What are the key things I have to find? I need to know A, B, and C in order to find vertices, covertices, foci, right? I need center. Yes? So what of that can I get from my equation? Okay, let's start with center. What are my center coordinates? Okay. And they are asking me to graph this, so I'm going to go ahead and plot things as I go. Okay, there's my center. What else can I pull out of my equation? Okay, so how do I know which of those is my a squared and which is b squared? Perfect. Bigger numbers, a. So in this case, a is a 6, and it's paired up with the x coordinate. And then b is 5, and it's with y. Okay, so can we mark those on our graph? We're going to go 6 in the x direction. And what are we going to call that? One of our vertices. Okay. What are the coordinates of that point? Okay, so I moved in the x direction, which means I'm changing my x coordinate of my center point, right? I'm making that go up 6 and down 6. So my other one should be at -5, -3. All right. Covertices says we have to go 5 in the y direction. So I'm going to change my y values by going up and down 5. So my covertices, if I add 5, I'm at 6, changing y. So 1 adding 5 puts me at 2, and subtracting 5 puts me at 1, -8. We okay with that? All right, now technically I could go ahead and draw my graph in, my ellipse. What have I not put in here yet? The foci. So let's figure out the foci. To do that, we need to know C. And what was the relationship for A, B, and C in an ellipse? Okay, so it would be a squared minus b squared square rooted, right, to get C. So 36 minus 25 is how much? So I get a C value of the square root of 11. It's not as fun, right? It's nice when they work out perfectly, nice integer value here. But square root of 11 is about what? Or it's between what two numbers? It's between 3 and 4, a little closer to 3. Okay, so we can mark on our graph, we're going to move a little more than 3 spaces in the same direction as we did for vertices. So we'd have a focus around there. And about there. Now, in terms of how I'm going to expect you to write the coordinates for that, were we changing the x or the y coordinate when we moved from center to those foci? We were changing x. So go to your center point, which was 1, -3, and we're going to change the x. We want to add and we want to subtract a little more than 3, or a square root of 11 from it. Okay? So for the ones that come out with square roots, I'm okay with you leaving like that, 1 plus minus root 11. But if it came out a nice integer, I'd expect you to give me the exact coordinates. Okay. Have we given all the key features for an ellipse? Okay, let's move on to the next one. What shape is our next one? How do we know it's a hyperbola? The minus sign in between. Okay, we've got it equal to 1. There's a minus sign. Hyperbola. All right. So picturing graphing a hyperbola, what things do we have to do? We're going to be making a box. In order to make the box, we need to know a center and an A and a B. Okay. So what's my center point? Agree, disagree? Yeah? Okay, what about A and B? How do I know that the first term there, that 16, was my A squared? A is always first. Perfect. So A is 4, and it was with X. B is 3, and it's with Y? Okay, so let's draw our center. All right, and then we're going to make our box. So we want to go 4 in the X direction. What am I going to call those? The A from center out to A spaces from the center is vertices. Okay. So what are my vertices? What are the coordinates? Okay, so I'm going to add and subtract 4 from that X coordinate. Yes? So -1 minus 4 would be -5, comma 4, and -1 plus 4 would be 3, 4. Okay. Then my B piece, we're going 3 in the Y direction. I'm not going to call those anything though, right? Because they're just there to make my box. So let's draw our box in. And then draw in your diagonals. And again, my board is not cooperating very well today. But you've connected all of those 4 points you plotted, right, to make a nice box? Okay. How do I know if this is going to have branches up and down or side to side? Find your vertices, right? Where was your A piece? So vertices, we said we're moving in the X direction. So I would have branches here and here. Yes? Okay. What do we need yet? We need foci and asymptotes. All right, let's find foci. C would be the square root of what? A squared plus B squared. All right, so A squared and B squared, we've got 16 and 9. Adding them, we get 25. Square root would be 5. Okay, this one worked out nice. So we're going to go 5 in the which direction? X, same as vertices. Okay. Coordinates for the foci. We said we're moving in the X direction, so we're going to take our center point, right? We're going to take -1 plus and minus 5. So adding 5 gives me 4, and subtracting 5 gets me -6. We okay with those? All right, last thing we want to find are the asymptotes. Think of y equals mx, right? The b we're getting in there because of the y minus kx minus h pieces, that'll fall in there. So y, go back to your equation. In our equation, we had a y minus 4 chunk, right? So we've got y minus 4 equals plus minus our slope, and then x minus h, which in our equation is an x plus 1. So all we have to do is find our slope. How much did we rise from center out to this top corner over here? We rise 3 and we ran 4. Yes? Okay. I'm going to pause the video. I want you guys at your tables to try questions 3 and 4. Okay? As I see you starting to finish 3, I'm going to start writing it up on the board. I'll let you know when it's ready for you to check. Okay? So you should have had time to work through question 3. Let's take a look here and check it. Are we agreeing that it's a hyperbola? Yes? Okay, clue there is the minus sign. First step on this one would be to divide that 100 out. So we have 25 divided by 100 reduces to 1/4. and 4 divided by 100 reduces to 1 over 25. Okay. Your center, double check that you have the center written correctly. This one is turned around, right? Your y piece was first, so you have to be very careful when you write your center that you get your coordinates in the right order. It's always the x one first. So -3, 4 for our center. I found a to be 2 since the first term is a 4, that's a squared. B would be 5. The a is paired with y and the b is paired with x. So from my center point, I went up 2 and down 2, and I went left and right 5 each, and made my box and drew in my branches touching the vertices. Yes? Okay. Then we did c being the square root of a squared plus b squared. It comes out to be the square root of 29. Again, it's not a perfect integer value for us, but square root of 29 is between what two numbers? It's between 5 and 6. So estimate about 5.5 from that center point to plot your foci. Okay? And then last step, we wrote in our equations for the asymptotes. Again, looking at our pieces here, our y value is 2. That means we're rising 2 and we're running 5. So we have a slope of 2/5. Questions on anything for number 3? Okay, where are you at with number 4? Do you need more time? Okay, let's work through number 4. What's my first step going to be? Divide out the 144. All right, so we have x minus 3 squared over what? 16. And then y minus 1 quantity squared over 36 equaling 1. All right, so what shape is it? It's an ellipse. We know that because of the plus sign in there. Key features for an ellipse, we need vertices, covertices, and foci, right? And the center point. So my center based on my equation is what? 3, 1. Okay. And how about A, B's, and C's? What's A? A is 6 and it's with y. B is 4 and it's with x. Let's go ahead and find C. It's an ellipse, so we need a squared minus b squared, square rooted. So 36 minus 16, we end up with the square root of 20. Yes? We good with that? Okay. Let's plot what we know. We are going 6 spaces in the y direction to get a vertex. We need to go 4 spaces in the x direction. Those are my covertices. And that's really enough to draw my ellipse shape, right? We just want to connect those dots. Okay. We should put foci in there though. Square root of 20 is about what? Between which two numbers? Between 4 and 5, so we'll go about 4.5 from the center in the same direction as the vertices. All right, so let's figure out coordinates for foci, vertices, and covertices. We can start with vertices. All right, so vertices, we went 6 in the y direction, which means we're going to change the y coordinate, right? So adding 6 gets me the 0.37, subtracting 6 gets me 3, -5. Okay. Covertices, we are going 4 units in the x direction, which means we're going to change our x coordinate up and down by 4. Adding 4 gives me 7, 1, and subtracting 4 gives me -1, 1. Okay. And then foci, we do the same thing we did with the vertices, right? We're going to change our y coordinate. So center is 3, 1. but we're going to add and subtract a root 20 to that y coordinate. All right, questions so far? Okay, the last couple, instead of giving you the equation and asking you to pull all the details out and graph it, we're doing the reverse. I'm giving you the details, I want you to write the equation. All right, I put some grids up here. I know you don't have it in your paper, but I think it's much easier if you kind of sketch it out. Okay, so we are told the endpoints of the major axis are at -2, 5, and -2, -3. What does that give me? What do we call the endpoints of the major axis? Those are your vertices. Okay, so where would the center point be? Halfway between them. How far is it to go from a +5 here to a -3? 8 spaces. So if we moved 4 in any direction, right, from either vertex, that's going to be my center. So what's H and K? Where did I put my center point? -2, 1. Okay. And then they also said the endpoints of the minor axis are -4, 1 and 0, 1. What does that tell me? Okay, those would be my covertices. So when I think about writing my equation, do I need foci? Do I need C at all for my equation? No, then don't bother finding it. All right, what do I need? I need A and B. Can I tell A from my picture? A is the distance from a center to a vertex. So how many spaces did I go from center to vertex? I went 4. And I went in which direction? Okay. And then from center to covertex is 2, which would be what letter in my equation? B. So we know B is 2, and this one moved in the x direction. So we really have everything we need to write our equation. All right. We know it's an ellipse, so we can start out with our basic format. In an ellipse, we always put the x piece first and then the y. Okay, so I'm going to have x minus h. So x minus -2 would be +2 squared. And then I need y minus k, so y minus 1 squared. And then my a's and b's can move, right? So I have to go back and look. We said a was 4, so squaring it gets me 16, and we said it was paired with y. So I'm going to put a 16 under y. And we said b was paired with x, so under my x piece, 2 squared would be a 4. Okay? So you actually have a little less work on these questions. You don't need to find quite as many pieces. All right, question 6. It's another ellipse. Go ahead and plot what we know. We have covertices at 3, 3 and 3, -5. What does that get me? Just that little bit of information tells me 2 things. I can find B from it, and I can find the center, right? The center is halfway in between those. So they're a total of 8 spaces apart. We go 4 from any of those dots. My center has what coordinates? Okay, and how far is it from center to a covertex? We said it was 4, so I know that B is 4, and it was moving in the y direction, vertically. Okay, then they tell me that the foci are at 0, -1, and 6, -1. Well, what does that help me figure out? That tells me C, which I don't need in my equation, but I can use it to help me figure out A. So C is 3 and it's with x. That means A is going to be with x as well, right? And it's an ellipse. So we have A squared minus B squared is equal to C squared. Yes? Okay, plug in what we know. B was 4, so this would be 16. C was 3, so squared would be 9. We add 16 over with the 9. A squared is 25. And we know that A is 5, but I really need the squared version in my equation anyway, right? So it's an ellipse. X is always in the first position. Let's plug in our center. Our x coordinate is 3. Our y coordinate was a -1, so +1 in our equation. And then A we said was going with x. So under my x piece, I'd have my a squared. And B was 4, so I'd have a 16 here. Questions on that one? Okay, I'm going to pause the video. The next one is similar. What's the difference? It's a hyperbola. Okay, so go ahead and sketch out what you know. Again, I'm going to pause it, give you some time to try it. All right, we've been checking our work for question 7. Let's move on to question 8. I'm giving you the same information except I've already graphed it for you, right? So from our picture, what can we find? We can find A, we can find B, and center, and that's all we need, right? So let's start with center. My center is where my diagonals cross, right? Where those asymptotes cross. So what's this point? 4, -1. Okay. Now, from center to a vertex, which would be this point, how many spaces did I go up? Okay, so that tells me A is 5, and it's with Y. Okay. To go to the other side of my box, how many spaces did I move to? 3 spaces here, so B is 3, and it's with X. And now I just dump it in, right? It's a hyperbola, so we know we need a minus sign in there. We've got something squared on top. What goes in the first position on the denominators? The 25, A squared, and then 9. Okay, and now we just have to figure out, is it X or Y first? We said A was paired with Y. Okay, so we're going to have a Y, then an X. We need our Y coordinate of our center point. So Y minus the -1, Y plus 1, and X minus 4. We good with that? Okay. So keep in mind that the first review assignment that you got yesterday was all circles and parabolas and what was it, distance midpoint? Okay. This is all hyperbolas and ellipses. So make sure you take a few minutes to look at the stuff from last night as well. Okay? Test tomorrow.